Coming to the question number 1, it says the switch is closed at t equals to 0 with the capacitor uncharged. Find the value of I di by dt and d square I by dt square at t is equal to 0 plus. The diagram given is there is switch here, then a resistor and a capacitor. This is 10 microfarads, this is 1000 ohms. This switch is like this, so this is 100 volts and I of t is flowing in this. Now in this type of problems we need to do analysis for t less than 0, then t is equal to 0. So let us start with at t equals to 0 minus. The switch is closed at t is equal to 0. That means for less than 0 the switch is open. When the switch is open and they are telling that with the capacitor uncharged. So for t less than 0, that is when this switch is open, the capacitor is not charged in this case. So we can say capacitor is uncharged, which implies voltage across capacitor for t less than 0 or 0 minus, and the current flowing at 0 minus, both are 0, or if you want to write it separately, is 0 volt and current is 0 ampere at t is equal to 0 minus. Now the next instant when the t is 0 plus, that is this switch is closed. So I'll draw the diagram again when the switch is closed. Now since there is the voltage across the capacitor is 0 volts for t is equal to 0 minus, and replacing the capacitor with the short circuit. If there would have been any voltage, I would have shown that voltage here. Since the voltage across the capacitor is 0, because they have told that the capacitor is uncharged at t is equal to for the time less than 0, so we are showing it as short circuit. So we need to find I at t is equal to 0 plus. So we can find now I at the instant t is equal to 0 plus. This diagram is for time t is equal to 0 plus when the switch is closed. So I can say I of t is 100 upon 1000, which will give me 0.1 ampere, or I can say I of 0 plus is 0.1 ampere. So from the question I have found I at t is equal to 0 plus. Now I need to find di by dt at 0 plus. So what I'll do, I'll draw the circuit at t greater than 0. So for that, Now the capacitor will come in picture. Ten microfarads, 1000 ohms, and this is 100. Now for this I'll apply KVL equation for time t greater than 0. That will be 100. Current flowing is again I of t minus 1000 I of t minus 1 upon 10 into 10 raised to minus 6 integral 0 to t I dt equals to 0. So differentiating equation 1 with respect to t will give me minus 1000 di by dt minus 6 I equals to 0. So it will be, can say, di by dt is equal to 0.1 into 10 raised to 6 upon 1000 I. Now we need to find di by dt at 0 plus, so we can say at t is equal to 0 plus di by dt will be 0.1 into 10 raised to 6 upon 1000 into I at 0 plus. Since this is I of t, so we can call it as at t is equal to 0 plus we have 0.1. So this will give me the value as, this will be minus, so you will get it as minus 10 amperes per second. So you have got di by dt at 0 plus to be minus 10 amperes per second. So we have got di by dt. Now we need to find d square I by dt square. So for that I'll differentiate this equation with respect to t. Writing the second equation again, which is di by dt is to minus 0.1 into 10 raised to 6 upon 1000 I of t. Now I differentiate with respect to t. So differentiating equation 2 with respect to t, it will give me d square I by dt square is equal to minus 0.1 10 raised to 6 upon 1000 di by dt. Now we need to find the value of d square I by dt square at t is equal to 0 plus. So d square I by dt square at 0 plus will be minus 0.1 10 raised to 6 upon 1000 into minus 10. So this will give you, so it will come to 1000 ampere per second square. So this is d square I by dt square at time 0 plus. So this is how we can find I at 0 plus, di by dt at 0 plus, and d square I by dt square. Now second problem you can try on your own. Can say switch is closed at t is equal to 0 with zero current in the inductor, find I di by dt and d square I by dt square at t equals to 0 plus. The diagram given is, it is similar to the previous one. Instead of capacitor you have the inductor, and initial current through the inductor is given to be 0. This is say 100 volts, 10 ohms, this is 10 Henry, and I of t. In this case, switch is closed as t is equal to 0 with 0 current. That means before t is equal to before the switch is closed, there is no current through the inductor. So t is equal to 0 minus, there will be no current flowing through this. So this will be open circuit, and I of 0 minus will also be 0. Just when the switch is closed, since it is not excited, again the current through the entire part will be 0, because this will act as open circuit as discussed previously. And then probably for t is equal to t greater than 0, you can write the KVL equation, and hence you can solve this problem.